All right, guys, today we're going to be focusing on angles. So first, definition of array is part of a line with only one endpoint. So a line segment had two endpoints, array only has one endpoint. The endpoint is called the initial point. The initial point always comes first in the name. So we've been naming things, and I've been telling you a lot that it doesn't matter the order. For array, it does matter. The initial point has to come first. So here's CD with a mini ray on top, or XW with the mini ray on top. All right, give two different names for this same ray. This ray has to start with P because that's your initial point, but you could have PC or PJ. Use the diagram of the intersecting lines to answer the following questions. Give another name for ray EF. And it is a ray, so we still have to start with E, but we could do EJ. Are the ray EJ and JE the same ray? No. Okay, EJ starts at E, but JE starts at J. So no, they have different initial points. Are EJ and EF the same ray? So they have the same initial point. That's good. So we have EJ and EF. Those would be the same. Yes, same initial point. Okay, and they're on the same line. So they can't just both start with E. They also have to be on the same line. Definition of opposite ray are two rays with the same initial point, but going in opposite directions. So here, they could both start at A, but I could have array AC and array AB. They both start at A, but they're going opposite directions. All right, are EJ and FJ opposite rays? They don't have the same initial point. I can tell right now without even looking at my picture that they both don't start with E. So no, different initial point. JF and JE. So they do both start with J. So now let's take a look. JF and JE, those are opposite directions. So yes, they are opposite rays. HJ and HG, they both start with H. So that's a good sign. So HJ and HG are both going the same direction. So no, they're not opposite rays, and they're the same ray because they're going the same direction. Definition of an angle. An angle is two rays with the same initial point. So this one, our initial point is B, and we have a ray extending to C and a ray extending to A. The sides of the angles are the rays. The vertex is the initial point. Name the vertex and sides of the largest angle. So our vertex is the point Q, which is a capital Q. And then the sides, so we would have ray QS and ray QP. And they have to start with Q because that's your initial point, or in this case, in an angle, our vertex. All right, so next page, naming angles. There are three methods for naming angles. So the angle is named by three letters, and the angle symbol is in front of the letters. And the vertex has to be in the middle. So there's a couple ways to name this one, but you do your angle symbol and then ABC, or you could go the other way and do CBA. But B has to be in the middle because it's your vertex. Method 2 is the angle is named with the number inside of the vertex, and we would still use our angle symbol. So this would be angle 5. And that's really the easiest way, but it has to be numbered on your diagram. Method 3 is the angle is named with the letter of the vertex and the angle symbol in front of the letters. So this one just has the vertex. It doesn't have other letters. So this one is angle G, like so. Method 3 can only be used if only one angle has that vertex. So if I had another ray here, then both of these have the vertex of G, and I wouldn't be able to use method 3. So keep that in mind. Mostly we'll use methods 1 and 2. Name all possible angles in the diagram below. So you have angle 1, angle 2, but then you also have this third angle where they would be combined. Okay, but they didn't label them, so we'll leave it off our list. This one, we have XPW here. XPW. We have angle WPJ. And then we also have the largest angle, XPJ. Okay, all three of those. And this is a good example of we can't use method 3 because angle P could be any of those three. It's not clear enough. All right, classifying angles. Angles are measured in degrees from 0 degrees up to 180 degrees. Acute angles are any angles that are between 0 and 90. Okay, so there's little and acute angles. Right angles are exactly 90 degrees, and a lot of times they have this box in the corner to show you that they're 90 degrees. Obtuse is between 90 and 180, so larger than a right angle, but not quite flat. And then a straight angle is a straight line. So you'll sometimes also see this curve here to let you know it's perfectly flat. Name and classify all angles in the figure. So let's start here with WQP. Angle WQP is less than 90 degrees, so it's acute. Then we can do PQR is less than 90 degrees and acute also. RQS, same thing, less than 90, so it's acute. I could also combine these two and have WQR. I believe that one is still acute. You could combine these two to get your right angle, angle PQS. Is a right angle. And then the angle on the outside, WQS, is larger than 90, so that one would be obtuse. And we don't have any straight angles on this page. I think I got them all. Definition of congruent angles are two angles that have the same measure. So let's say that this is 30 degrees. They are both 30 degrees. And this little angle arc here shows us that they're congruent. Okay, it's just like how we use the tick marks for segment lengths. These little arcs show us that they're the same. All right. I think that's it for today. Yep, we went through all of them. So today you just have the worksheet in your packet. So this one is on page 20. So you'll check it with the key on Canvas and then submit a picture of it on Canvas. There's no Delta Math today.